Hello, I am Dr. Imran Khan. Today we will discuss microprocessors versus microcontrollers. A microprocessor is an integrated circuit which has only the CPU or central processing unit inside it. Examples of microprocessors are Intel Pentium 1, 2, 3, Pentium 4, Core 2, Core i3, Core i7, Core i9, etc. These microprocessors don't have RAM, ROM, and other peripherals on the same chip. A system designer has to add them externally to make them functional. Applications of microprocessors include desktop PCs, laptops, notepads, etc. But this is not the case with the microcontrollers. A microcontroller has a CPU in addition with a fixed amount of RAM, ROM, and other peripherals all embedded on a single chip. At times, it is also termed as a mini computer or computer on a single chip. Today, different manufacturers produce microcontroller with wide range of features available in different versions. Some manufacturers are Atmel, Microchip, Texas Instruments, Freescale, Philips, Motorola, etc. Outline. So, outline of our lecture is first we will discuss microprocessors, then we will discuss some examples related to microprocessor-based systems, then we will discuss microcontrollers, and in the end we will discuss the differences between microprocessors and the microcontroller. Microprocessor. Microprocessor is a silicon-based integrated chip with only a central processing unit. It is the heart of the computer system, which is designed to perform loads of tasks that involve data. Microprocessors don't have RAM, ROM, I/O ports, timers, and other peripherals on the same chip. They are to be added externally to make them functional. Microprocessor consists of ALU or arithmetic logic unit, which handles all the arithmetic and logic operations. The control unit, which manages and handles the flow of instruction throughout the system. And register array, which stores the data from memory for fast access. They are designed for general purpose applications such as logical operations in a computer system. In simple terms, it's fully functional CPU on a single integrated circuit that is used by a computer system to do its work. So, processor, we have three different types of processors: general purpose processors, single purpose processors, custom single purpose processor. So general purpose processors can perform a variety of computation tasks. Single purpose processors can perform only one particular computation task, and the custom single purpose processors can perform non-standard tasks. A custom single purpose processors may be fast, smaller, and may have low power dissipation, but they have high NRE or non-recurrent engineering cost, longer time to market, and they are less flexible. Processors processor technology. So the architecture of the computation engine used to implement a system's desired functionality is called processor. So processor doesn't have to be programmable. So all the processors are not general purpose processors. So as we discussed in the previous slide, we have three different types of processors. So here uh, names and the architectures of these processors you can see. So this one is the general purpose processor. So here you can see this is the architecture of the general purpose processor. So here you will find this controller, this increment register, program counter, and this is program memory, and here you will find this data path, general ALU, and data memory. And this is application specific processor. So here you will find this controller, program memory, data path. So here you will find this custom ALU, and this is the single purpose processor. So here you will find this controller, this data path, and data memory. So in next slide we will discuss in details about these different types of processors. So general purpose processors, so here you can find the architecture of the general purpose processor. So here you will find this general ALU or general arithmetic logic unit. So these general purpose processors are programmable devices used in variety of applications. So these are also known as microprocessors. So general purpose processors have program memory, general data path with large register files, and general ALU. So the general purpose processors also have some user benefits like low time to market and low non-recurrent engineering costs. So it has high flexibility. Some examples of general purpose processors are Pentium computers developed by the Intel. Single purpose processor. So single purpose processors are the digital circuits designed to execute exactly one program. So these are also known as coprocessors, accelerators, or peripherals. So here you can find the architecture of this single purpose processor. Okay, so the single purpose processors have some features like they contain only the components needed to execute a single program. So they don't have program memory. They also have some benefits like they are faster, they have low power dissipation, and they are smaller in size. Application specific processors. So here you can find the architecture of the application specific processor. So here you will find these controllers, increment registers, program counters, program memory, these data paths, registers, custom ALU, and the data memory. Okay, so these application specific processors are programmable processors optimized for a particular class of applications having common characteristics. So these application specific processors have some features like they have program memory, optimized data path, and all. They also have special functional units. So these application processors also have some benefits like they have some flexibility, but they have less flexibility compared to the general purpose processors, and more flexibility compared to the single purpose processors. So they have good performance, they have smaller size than the general purpose processor, and less power dissipation compared to the general purpose processors. Okay, so the system bus. So here we will discuss the system bus. A system bus is a single computer bus that connects the major component of a computer system, combining the functions of a data bus to carry information at an address bus to determine where it should be sent, and a control bus to determine its operation. So here you can find this central processing unit or CPU. It is connected to the memory and different input output devices via these system buses. Okay, so here you will find this data bus, address bus, and control bus. So here you can find these data buses. These are bidirectional, and the address bus is unidirectional. uh, Similarly you will find this similarly you will find this is control bus. Okay, so it will carry basically the control signal, and it will determine its operation. Okay, so here you can find one example of microprocessor based system. Okay, so here we have this microprocessing unit or CPU. It is connected to different input and output devices. Okay, so here we have some input switches and output LEDs. Okay, and this is basically the memory, ROM, and read write memory. Okay, so these all different components are connected to CPU via these system buses. Okay, so here you can find this is the system bus. So here we have the block level diagram of microprocessor. Okay, so here you can find this arithmetic logic unit, register array, and the control unit. Okay, so ALU or arithmetic logic unit, uh, or arithmetic logic unit handles all the arithmetic and logical operations, and the control unit basically it manages and handles the flow of instruction throughout the system. And this register array stores the data from uh, memory for fast access. Okay, so this is basically the global block level diagram of CPU. Okay, so we will discuss here microprocessor architecture. Okay, so as we already know that MPU or microprocessing unit communicates with memory and input output devices using the system bus. Okay, so here we have this address bus, data bus, and the control bus. Address bus is unidirectional, and it is used for communication with memory and different IO addresses. Okay, so data bus is bidirectional. It will transfer binary data and instructions. So control lines basically used for these read and write timing signals. Okay, so here we have another example of microprocessor based system. Okay, so here we have this microprocessor unit or MPU, and it is connected to different devices by using these system buses. Okay, so here we have this control bus, data bus, and the address bus. Okay, so by using these different buses, our CPU is connected to different devices like ROM, read write memory, input ports, switches, output ports, and different LEDs. Okay, so this is how you can develop the microprocessor based systems. Okay, so our microprocessor based systems, they have system hardware and the system software. Okay, so the system hardware is basically the discrete components like microprocessors, memory, and different input output devices. Okay, so the components connected by buses like address, data, and control buses, which we already discussed in the previous slides. Okay, so the system software is basically group of programs that monitors the function of the entire system. Microcontroller. Microcontroller is is like a mini computer with CPU along with RAM, ROM, serial ports, timers, and I/O peripherals all embedded on a single chip. It is designed to perform application-specific tasks that requires a certain degree of control such as TV remote, LED display, smart watches, vehicles, traffic light control, temperature control, etc. It is a high-end device with a microprocessor, memory, and input-output ports all on a single chip. It is the brain of a computer system which contains enough circuitry to perform specific function without external memory. Since it lacks external components, the power consumption is less, which makes it ideal for devices running on batteries. Simple speaking, a microcontroller is a complete computer system with less external hardware. Okay, so this we already discussed that the microcontroller is basically integrated electronic computing device that includes all the major components on a single chip like microprocessor, memory, and different I/O ports. So this is the block level diagram of our microcontroller. So the microcontroller is a single chip computer. So it has uh, everything, RAM, ROM, I/O ports, everything on a single chip. Okay, so examples are Motorola 6811, Intel 8051, and the other microcontrollers here. You can find the other like this Zlog, Z8, and PIC 16X, etc. So here you will find everything: CPU, RAM, ROM, I/O ports, timer, serial ports, everything on a single chip. Okay, so components of microprocessor and microcontroller. Okay, so they have the CPU, central processing unit, I/O devices like input output devices, buses, system buses like address bus, data bus, control bus. Okay, so the memories like RAM and ROM, timer, interrupt, serial port, parallel ports, etc. Okay, so these all components are expected in our microcontrollers. So the input output ports may include input devices may include switches and keypads. Okay, so they provide binary information to microprocessing units. Similarly, the output devices may include LEDs and LCDs. Okay, so they will receive binary information from the microprocessing unit or the microprocessor. Okay, so the microcontrollers, so they have some support devices like timers, analog to digital converter, serial input output ports. Okay, so the common communication lines used for the communication in microcontroller or microprocessor is the system bus, which we already discussed in detail in our previous slides. Okay, so here you will find this microcontroller unit or MCU. Okay, so they have this microprocessing unit, MPU, and this program memory, data memory, I/O ports, port devices, everything on a single chip. Okay, so this is the block level diagram of our microcontroller unit. So this is the memory. It basically represent a 16-bit system. Okay, so here you can find this memory is basically the storage device. These has the unique addresses and registers for storage. Okay, so every register has the unique address, binary address. Okay, so here you can find the unique binary address. So this basically represents the 16-bit system. Okay, So the major categories of our memories are read-write memory or read-only memories or ROM. Okay, so here you will find the unique addresses and the 16 registers. Okay, so these are basically the data lines. So this basically represent the memory. Okay, the microprocessor versus the microcontrollers. Okay, so we will discuss the difference in details here. The key difference between both the term is the presence of peripheral. Unlike microcontrollers, microprocessors have no built-in memory, ROM, serial ports, timers, and other peripherals that constitute a system. An external bus is required to interface to peripherals. A microcontroller, on the other hand, has all the peripherals such as processor, RAM, ROM, and input-output devices all integrated in a single chip. It has an external controlling bus which is not available to the designer. As all the components are packed in one chip, it's compact, which make it ideal for large-scale industrial application. Microprocessor is the heart of the computer system and microcontroller is the brain of the computer system. Okay, so here you can find these points in the list. Okay, so like let's discuss microprocessor. CPU is a standalone uh, device with RAM, ROM, and IO timers. Everything are separate. Okay, while in microcontroller, CPU, RAM, ROM, IO, and timer are on a single chip. Okay, designers can decide in microprocessor. Designers can decide uh, the amount of RAM, ROM, and IO ports. But in case of microcontroller, uh, everything like RAM, ROM, IO ports are in fixed amount. Okay, so this microprocessor is expensive, and this microprocessor is little cheaper. Okay, so these microprocessors are versatile, and they are basically general purpose. They have high processing power, high power consumption. Instruction sets focus on the processing of intensive operations. Okay, so typically they are 32-bit, 64-bit, or nowadays even 120-bit systems. Okay, so here in our microcontroller, so these are designed for the low power applications, and they are usually single purpose, and they have low power consumption. They can perform bit level operations. So in case of microcontroller, instruction sets focus on control and bit level operations. So they are typically 8 or 16 bit devices. Okay, so typically a single cycle or two stage pipelines systems are available in the microcontrollers. So some popular examples of microcontroller are 8051 microchip technology PIC microcontroller, Atmel AVR microcontroller, Texas Instruments MSP 430 16-bit microcontrollers. Okay, so these are some popular microcontrollers available in the market. So similarly, we have a lot of popular microprocessors. So most of them are developed by the Intel, like 8088, 8086, similarly, and many other microprocessors like Pentium 1, Pentium 2, Pentium 3, Pentium 4, Core i3, Core i5, Core i7, and nowadays even Core i9 microprocessors are available. Okay, so this was all for today. So if you have any question, please feel free to contact me via email. Thank you very much for today. See you next time.